Good day, students and viewers. You are welcome to the studios of Maths X. We are still on set theory. In our previous video, I taught you key symbols in sets, and I did link those key symbols in sets to our set builders notations in our previous video. I believe you were thoroughly enlightened and you can write your own set builders notations given the exercises I gave in the description of that previous video. Today we're going to press forward some more in set theory. But before I go on with today's presentation, I will want to urge you, my dear student and viewer, to subscribe to our videos. Do like and share our videos. As you do so, thank you so much. In today's video, I want to start by saying that I had rather introduced to you sets in our first video, and in doing so, I did talk about set descriptions in that same video. In the video following that, we talked about types of sets. And from types of sets, we went into two videos involving set operation. I would urge you, my dear students and viewers, to make good your understanding of set theory. Do go through all those videos. It would give you a lot of value as far as this topic is concerned in mathematics. In our video today, my dear students and viewers, I will want to talk about something called properties of sets. So we are on properties of sets. In our video regarding set operations, I did expose to you operations like union, intersection, and complement of sets. To further simplify these operations of sets for our dear students, mathematicians have come up with certain laws. These laws, they are like maybe the laws of indices that you have, yes, that you know of. So these laws are also laws in sets, yes, and these are the properties of sets. We'll talk about at least 9 of them using Venn diagrams to describe with examples. Happy viewing. To aid in our understanding with examples, I will come up with a universal set mu and 3 subsets of that particular universal set. That's sets A, B, and C. And I will write the universal set using set builders notations. So our universal set mu, our brace, so that X, recall this symbol, is an element of, so X is an element of a set of natural numbers such that, you should recall this, such that X is less than or equal to 10. This is our set builders notation for our universal set mu. Then we're going to have subsets. Subsets A will be 1, 2, 3, and a 4. We're going to have another subset B. This will be a subset of even numbers 2 to 8. So that will be 2, 4, 6, and 8. And then last but not the least, another subset C. This subset will be 2, 3, 5, and 7. So to help us in understanding, we'll have to use these sets because for each of the laws that I'm going to state, I will come up with an example to explain the law and also a Venn diagram description to foster better understanding of the particular laws I will bring up. So the first law I want us to talk about is called the commutative law. That's the first property of sets. It's called the commutative law. What does the commutative law say? It says that if I have A union B is equal to B union A. This is for its union. Let's take an example of this along with Venn diagram representation of the union of sets in the commutative law. So this is our set A. Our set A is 1, 2, 3, and 4. Union set B, that's set B, which is 2, 4, 6, and 8. So our A union B, and we know what union is. It was the first set operation I explained or I talked about in our video regarding union of sets. It's a collection of all the elements of two or more subsets without what? Repetition. So going by that, we are going to have here that our union of this set, I'll write it well, will be a 1, a 2, a 3, a 4, a 6, and a 8. That is our A union B. And that if you interchange B union A, B union A will have the same values. Remember that our union is a collection of all the elements in a particular, in two or more sets or subsets without what? Repetition. So when you look at that, that is what you end up having. Let's put forward a Venn diagram representation of this. To do that, I'll have my two circles. That's my subset A and subset B. My rectangle to cover them. All right. This is my symbol for mu. And to express this in Venn diagram, I will shade. The region that best expresses this in Venn diagram will be to shade everything about A union B. This is how to express this in Venn diagram representation. Let's talk about still on the commutative law. This is for its union. Let's talk about its intersection. In the commutative law, it also states that A intersection B is the same as B intersection A. Let's look at what our A is. This is A. We have here that 1, 2, 3, and 4 intersection our B. This will be a 2, 4, 6, and an 8. So what is A intersection B? What is common? We know what intersection is. That was the second set operation I talked about. So for intersection, it talks about what is common between two sets. So what is common? I see 2 and 4. 2 and 4. So that is our 2 and 4. In terms of its Venn diagram representation, Venn diagram representation here we'll talk about, once again, two sets and our mother set mu, or our universal sets. The region that best describes intersection in the commutative law is this region here. This is the region that describes it perfectly. So that's it. This is where you have your 2 and 4 inside. So the 2 and the 4 will occur inside here. All right. Let's go to the second law. I will take off this part of the board, my dear students and viewers. I believe you've seen this because I have to take it off also. You've seen this? The subset A, subset B, subset C, because I'll be using them throughout the properties of sets. Our second property is the associative law of sets. This law, in its union, states that A union B union C will be equal to A union B union C. This is what this law says. And as an example, we know that B union C alone, we know is our B was 2, 4, 6, and 8. Our union C, C was 2, 3, 5, 7. So B union C, clearly, my dear, B union C will be like the union, collection of all, repeating none. That will be 2, 3, 4, 5, 6, 7, and 8. That's our B union C. Then let's work on A union B. Our set A was 1, 2, 3, and 4. Then our union of B union C, which is this, all right, which is this. This is 2, 3, 4, 5, 6, 7, 8. All right, so this will be 1, 2, 3, 4, 5, 6, 7, 8. This is our B union C. This is our A union B union C. And it will also be this same expression. This is the associative law, the union for the associative law of sets. That is what it is. Let us put forward a Venn diagram representation of this union of sets under associative law. We'll come up with 3 subsets. So that is a first circle, a second circle, and a third. Anyhow you draw it, the order doesn't really matter. So we have our set A, our set B, our set C. This is our universal set mu. The region that defines this expression will be, I'm shading them, in its union. I'm getting a bit careful now. So that is the region that best defines the associative law under its union. Let's go for the intersection in the associative law. For the intersection, we have that A intersection B intersection C will be equal to A intersection B intersection C. By this, let us start again from B intersection C. So this was our B union C. Let's work on our B intersection C. When we do that, our B intersection C will be 2 is common. Only 2 is common. So that's it. Having gotten that, let us also work on our A intersection B intersection C. So for this, that our set A was 1 or is 1, 2, 3, and 4. Then of course intersection 2, which is our B intersection C. So clearly that is what? 2. Because only two is here and here. Intersection talks about the element that is common to the 2 sets. So that's what we have. Then let's put forward a Venn diagram representation of our intersection under associative law. I have to take down this part of the board, my dear students and viewers. For our associative law intersection under associative law, we'll have here that we'll do 3 circles again. Like I said, order does not matter. my subset A, B, and C. So this is my universal set mu. So the region that describes our intersection under the associative law is this region, just here. This is what describes that. My dear students and viewers, this is as far as we go in this video. If you have any questions or issues about the lesson we've just learned, do send us a comment or a chat. We'll be more than willing to attend to you. Do watch out for the second part of this video on properties of sets. Until then, keep watching the videos of Maths X, like, share, and subscribe. As you do so, God bless.